Number 1 says to solve for x. So the first thing we want to do is we want to get one of the radicals by itself on one side of the equation. So I'm going to just subtract this radical x from both sides. So what happens is I isolated the radical x plus 9 on the left-hand side of the equation, and that leaves me with negative radical x minus 9 on the right. And you could write that in either order. Okay, so now, in order to get rid of a radical, we square both sides of the equation. So I'm going to square the left side of the equation and square the right side of the equation. So on the left, the square and the radical cancel each other out, leaving me with x plus 9. And on the right-hand side of the equation, when something is squared, it means you have two of them. So I'm going to rewrite this binomial twice. That way I can double distribute it out. So let me just bring down this x plus 9. And when I double distribute, negative radical x times negative radical x will be positive x. The radical cancels out. Negative radical x times negative 9 will be positive 9 radical x. Negative 9 times negative radical x is positive 9 radical x. And then negative 9 times negative 9 is positive 81. Okay, now we still have radicals within our equation. So we have these radicals right here. So first thing I'm going to do is I'm going to combine them. And then once I combine them, I'm going to get those by itself on one side of the equation. So I'm going to be left with x plus, when we combine those to give us 18 radical x, and we bring down the 81. So to get the radical by itself, I'm going to subtract the x and subtract the 81 from both sides of the equation. So these cancel off, and 9 minus 81 is negative 72. Over here, those cancel off, leaving me with 18 radical x. So let's just divide both sides by 18. That way we can get the radical x by itself. So negative 72 divided by 18 would be negative 4. And the 18's canceled off, leaving me with radical x. Now again, to get rid of a radical, you can square it. So I'm going to square both sides of the equation. And negative 4 squared is 16, so I'm left with 16 equals x. Now when solving radical equations, it's very important to check, because sometimes your solutions will not check, and we call those our extraneous roots. All right, so let's just go back to the original equation. Wherever you see an x, let's plug in 16. So we have radical 16 plus 9 instead of x plus 9. And then plus, instead of radical x, we'll write radical 16. And I'll bring down the equals negative 9. All right, well, 16 plus 9 is 25. So we have radical 25 plus radical 16 equals negative 9. And if we take the square root of 25, it's 5, and the square root of 16 is 4. Now, if you add 5 plus 4, that gives you 9. That doesn't equal negative 9, so this actually doesn't check. So what we wind up with is no solution. Now, I just want to point out one thing. This question was multiple choice, so because it's multiple choice, instead of doing all of this work, you could just take the answer choices one by one and plug them back into the equation, check them into the equation to see if they work. And it's actually a time saver to do that, because if you have to check your solutions anyway, might as well just take the solutions that are given to you in the answer choices and try those out. Number 2 asks us to basically write the equation of a circle whose center is negative 4, 5, and radius is 6. Okay, now the formula for any circle is x minus h squared plus y minus k squared equals the radius squared, where h and k are just the coordinates of the center of the circle. So h would be your x-coordinate, which we have negative 4, and k would be the y-coordinate, which we have as 5. So if we take these values and substitute them into our equation, I'll have x minus, now I'm going to take this negative 4 and replace it for the h, so minus negative 4 actually winds up changing it to a plus 4. All right, then we have y minus, well, over here, k would be 5. So we square that, and it's equal to the radius squared. Since our radius is 6, 6 squared is 36. Now, if you look at the answer choices, the answer choice actually is not there, but you do wind up with x plus 4 squared plus y minus 5 squared equals 36. So this is the correct answer. Number 3 asks us to factor, and when you factor, you always want to factor completely. Now, if you look at all 4 terms, you can actually pull out a 4 as well as an x. So that's what I'm going to do. I'm first going to pull out the greatest common factor. When you pull out a 4x, you're left with x minus xy minus 4 plus 4y. Okay, so all I did was I went through and just pulled an x out of each term. Now, if we look in the parentheses, we have 4 terms. And when you have 4 terms, that tells you we're going to have to do factor by grouping. We're going to group together the first 2 terms, group together the last 2 terms, and pull the greatest common factor out of each of them. All right, so this 4x in front we're just going to have to bring down. And let's open up a parenthesis. And when we do, out of the first 2 terms, here we can pull out an x. So when we do, it leaves us with 1 minus y. Out of the next 2 terms, you have to decide whether you want to pull out a positive 4 or a negative 4. But if we look in our parenthesis here, we have 1 minus y. If we want to be left with a 1 minus y once we pull out the greatest common factor out of these 2 terms, well, it looks like we're going to have to pull out a negative 4, because negative 4 divided by negative 4 is positive 1, and positive 4y divided by negative 4 is negative 1y, or just negative y. All right, from this point, we're again going to bring our 4x down. You can group together the x and the minus 4 as one of our factors, and then you can rewrite the common binomial right here and here, okay, as 1 minus y. So this would be factored completely. Now, when you look at the answer choice, letter B is written as 4x times 1 minus y times x minus 4. When you're multiplying, it doesn't matter what order it's written in, so this is the same exact answer as this right here. So letter B would be our answer. Number 4 asks us to take the cubed root of this expression. Now, whenever I do questions with cube roots, fourth roots, I always like to, off to the side, list out all of my perfect cubes. Okay, so if we start with the numbers, 1 cubed is 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed is 64. 5 cubed is 125, and I'm going to stop here because I could see this is already bigger than the 72 that's under our radical. Now, when we're talking about variables, as long as the exponent is a multiple of 3 or divisible by 3, it's going to be a perfect cube. So here's our first, let's say, 5 perfect cubes, and that list keeps going and going. All right, now let's go to our original problem. We could see as we look under the radical, not everything under here is a perfect cube. So when that happens, we have to break up 2 separate radicals. The first radical represents where all of our perfect cubes are going to go, and the second radical represents where all of our leftovers are going to go. Now, since 72 is not a perfect cube, we want to look at our list of numbers and say, well, what is the biggest perfect cube that divides evenly into 72? Well, this right here, the 8 is. 8 times 9 gives you 72. And I put the 8 in the first radical because that's our perfect cube, and the 9 is our leftover. Now, if we look at our variables, let's look at x to the 9th. X to the 9th is a perfect cube because the exponent is a multiple of 3. So I'm going to put that entire thing in our perfect cube radical. Y to the 15th is also a perfect cube because 15 is a multiple of 3. So I'm going to put that entire thing in our perfect cube radical. Z to the 4th is not. So what we want to do is we want to pull out the biggest perfect cube that we can. So we could pull out a Z to the 3rd. And what that leaves us with is 1 Z left over in our non-perfect cube radical. So now what we're going to do is we're going to take the cubed root of our first radical. All right, so the cubed root of 8 is 2. The cubed root of x to the 9th, all you have to do is take your exponent and divide it by the root. So since 9 divided by 3 is 3, you get x to the 3rd. The cubed root of y to the 15th, again, if you took 15 and divided it by the root, 15 divided by 3, you would get 5, so it leaves you with y to the 5th. And same thing with the z. The cubed root of z cubed is just z, because 3 divided by 3 is 1. And then you just take your leftover, whatever you couldn't get out of the radical, and you bring that down. So this would be your final answer.